Physics 101, static equilibrium homework, question number 4. We have a camping trip, and a man is on the camping trip gathering water for the campsite, fills up 2 buckets. We don't know which one is bigger. We don't know which one holds more. It says they're not drawn to scale, so we can't just look at it. We can't figure that out from that. But we do know that the rod he's using to carry the water, this rod here in the middle, is 1.51 meters long. And that's given for me. Your numbers are probably different. And we also know that the balance point, where the system is balanced and therefore at equilibrium, is not in the middle of the rod, but it's slightly askew from the middle here at that triangle. It is 0.0127 meters towards bucket 1. Okay, so the first part, we don't need any more information than what we've got to figure out that first part. Which bucket holds more water? Well, if we're assuming that it's the same water with the same density, then the mass is going to be proportional to the volume. And the one with the larger mass is going to have more gravitational force pulling it down. And if I have to shift the center of mass to the left, that means the bucket on the left is going to be heavier than the bucket on the right. We could also look at it in terms of torque. So if this is the pivot point, and that the arrows that I drew down are the forces, then the lever arm on this side is going to be the total length of the rod minus that little L that it is shifted towards it. It's got a smaller lever arm, which means it has to have more force to equal the same amount of torque. This one over here has a longer lever arm because it is the length of the rod, actually the length of the rod over 2, half of the rod. The length of the rod over 2 plus that little skewed shift of the center. So again, the shorter lever arm means it requires more force, and that means it's got more gravity pulling it down, which means that it has more water in it. All right, cool. The second part says, how much more water does it have? Okay, so the hard part here is that it's asking in terms of a percentage, but I think that's the only way we can actually do it. We know that the torques are balanced. Tau for bucket 1 is going to equal tau for bucket 2. Since that is the balance point, we have it balanced at that, not the midpoint, but at the point that's given in the problem. And that means that the force of gravity on 1 times the lever arm for 1, which we said was L over 2 minus little l. And the angle here is 90 degrees, so we don't have to worry about the sine term. On the right-hand side, we have force of gravity of bucket 2 and L over 2 plus little l. So we're essentially trying to find the ratio of the forces because we want to find a percentage. Think about a test grade. If I get like, if I get 75 out of 100 on an exam, I take the 75 divided by 100, multiply that by 100, and I get my percentage of 75%. If I can find the ratio of the forces, then I can find what percentage of one the other one is. And from that, I can get the percent difference. How much heavier? What percentage of it heavier is it? So I'm going to erase that to save some space. I know bucket 1 is the heavier of the two. I'm going to find what percent of bucket 2 bucket 1 is. It's going to be some number, since bucket 1 is heavier, it's going to be some number bigger than 1. And the difference between that and 100% is how much more percentage-wise bucket 1 has in it. If you didn't follow all those words, I'm going to show you here mathematically. I'm not going to put the numbers in. I can let you do that on your own, but I'm going to show you what it looks like. So force of gravity on bucket 1, and I'm going to divide the force of gravity on bucket 2 over Fg2. That's going to give us the percentage of bucket 2 that bucket 1 is. It's going to be more than 100% because bucket 1 has more force. And that's going to equal, and I'm going to divide this stuff over to the other side. So I get L over 2 plus little l divided by L over 2 minus little l. And actually we have those numbers, right? I know what L is, I know what little l is, so I can just plug those in. And it's going to give me some number 1 point something, 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 something. That point something, something, something on the right-hand side of the decimal is how much bigger, what percent bigger. So I'm not doing the math for mine, but just for example, I didn't put the numbers in. This is not what my answer is, but if it was 1 point, I don't know, 21, then it's 21% bigger because it's 21 is 0.21 bigger than 100%, where 100% is how big FG2 is.